So this question is of kinematics, and this question is a particle moves in a straight line, and so that at time t seconds after passing through a fixed point, its velocity v meter per second is given by v is equal to 6 cos 2t. So v is equal to 6 cos 2t. So find the two smallest. First part is find the two smallest positive values of t for which the particle is instantaneously at rest. So instantaneously at rest means v is equal to 0. So when we do the first part, obviously, because the particle is instantaneously at rest, so obviously v is equal to 0. So we will make this expression equal to 0 because we have substituted v equals to 0. So now when 6 moves on other side, so it will turn to 0 and we will get cos 2t is equal to 0, and 2t is equal to cos inverse 0, and it will turn to, cos is 0 at pi over 2. Okay, so 2t is equal to pi over 2, and it will be, this will be t equals to pi over 4, and we are supposed to find out two positive values. Okay, two smallest positive values of t. Now look that as you know, that period of the cos is 360 degrees. So if it is pi over 2, this is pi, 3 pi over 2, and then 2 pi. So the curve will be completed by using 3. The cycle will be completed. This is the curve for cos x, but our function is cos 2x or cos 2t. So it means now the cycle will be like this, like it will be 0 at half of this, that is pi over 4, and then at 90 it will reach to -1, and then from here it will move again upward, and because instantaneously at 0, this is t, this is v, so whenever v is 0, it is on t axis times axis, so it means it is 0 here and it is 0 here. Okay, so this way we get one value pi over 4, and the other value will be half of pi over 2 and pi, and that will be equal to pi over 2 plus pi over 2, so it will be 3 pi over 2, that will be equal to over 2 3 pi over 4. So the other value will be 3 pi over 4. So these are the two positive values of t when the particle is instantaneously at rest. Now the next part is that you have to find out the distance. Second part, you have to find out the distance between the positions of instantaneous rest corresponding to these two values. So when you are supposed to find out distance from the velocity, obviously you will integrate it to get distance. Okay, so when you integrate it with respect to t, you will definitely get the distance. So but you have to apply the limits here, obviously. So limits are when the particle is instantaneously at rest. So instantaneous rest, the particle when it is at instantaneous rest, the limits are pi over 4 and 3 pi over 4. So it means we will have pi over 4, 3 pi over 4 and cos 6 cos 2t dt. Now let's quickly get the answer of this. So it will be 6, as you can write 6 outside, so it will be sine 2t over 2, as you know the integration of cos 2t. So pi over 4 to 3 pi over 4. Now apply the limits, so it will become 3, so it will be sine 2 and into 3 pi over 4 minus sine upper limit minus lower limit sine 2 pi over 4. So we have applied the upper limit and the lower limit. So now it will be 3 I got by cancelling these two 3s are 6. So now this cancels this, it becomes 2, 3 pi over 2. So it's 3 sine 3 pi over 2 minus sine 90. Sine pi over 2 is 0, you know this factor will turn to 0. Sine, oh no, this factor will turn to 1, sorry. Sine 90 is 1, sine 0 is 0, sine 90 is 1. Oh, again sine 90 is 1, so 1. Now let's use the calculator to get the answer. So it is 3 bracket sine 3 pi 3 pi over 2 minus 1, bracket closed. So it is equal to 0.19 sine 3 pi over 2. Sine 3 pi over 2 is minus 1. Oh, sorry, I did a mistake when I was writing it on calculator. Sine, so it is like this, so it will be equal to, actually there is a problem in my calculator, so I write it sine 3 pi over 2 is minus 1, as I know it. So it will be minus 1 and minus 1, so it will be equal to 3 into minus 2, that is equal to minus 6. And you know distance we are finding, so distance is always positive, so we will take it as 6. So 6 meter, 6 is the answer for the v meter per second. So 6 meter is the answer. Then the other part is the greatest magnitude of the acceleration. This part you have to first understand. Greatest greatest magnitude means that greatest, how will we get it? Like when we will have the expression of d square a over d t, d square greatest no, acceleration is dv over dt. So when we will have d square a over dt, yes, d square over a, d square a over dt, d square a over dt square, when it will be like when its value is less than 0. Okay, when its value is less than, at the value at some value of, at some value of t, at some value of t, so then we will say that value uh, of at that value of t we will actually find out the value of acceleration. Acceleration is basically dv over dt, that is basically the acceleration. So for this value we will find out, and here we will get the answer. Okay, but at what value? When we will get d square a over dt square less than 0. So if it is d square a over dt square greater than 0, so then we will definitely have minimum value. Okay, so we are supposed to find out the greatest value. So greatest value is when the double derivative of a is less than 0 at some value of t. Let's do it and then find it, that which values of at what is the value of t where we are getting the acceleration, double derivative of acceleration less than 0. So as we know, third part, as you know, we have v is equal to 6 cos 2t. So when we will take derivative of v with respect to t, we will get acceleration. Okay, so it will be 6, and the derivative of cos is minus sine 2t, and the derivative of the angle will be equal to 2. So it will be equal to minus 12 sine 2t. This is the value of acceleration. A is equal to minus 12 sine 2t. Now let's take the derivative of this a. So dA over dt is equal to minus 12 cos 2t into 2, and this will be equal to minus 24 cos 2t. Now we need a double derivative of it, so we will find we will take derivative one more time. So d square a over dt is equal to minus 24, minus into minus plus 24, because the derivative of the cos, you know, is negative sign. So wait, I write it, minus sine 2t and then 2, so it will turn to positive 48 sine 2t. So double derivative we are getting positive 48 sine 2t. But now we have to find out the value of t at which this is greater than or less than 0. So for this you will definitely put this single derivative, equal to 0, because when you will put it equal to 0, then you will get the values of t here. Okay, so when you do this, so you will be getting like this. minus 12 cos 2t, sorry, minus 24 cos 2t is equal to 0. So here you get cos 2t is equal to 0. This implies that t is equal to the same pi over 4, and the other value we had, that was 3 pi over 4, that is 3 pi over 4. Now at these values of t, we check that are we what are we getting this, one by one we will check that are we getting this expression, this double derivative expression for acceleration is coming less or greater. So when we substitute pi over 4 at t is equal to pi over 4, so d square a over dt square will be equal to 48 and sine 2 pi over 4, that will be equal to, this will cancel, and you know sine 90 is equal to 1, and 1 times by 48 is 48, which is greater than 0. So it means that if we put this value, if we put this value of t, then we get minimum point, okay, minimum value of d square a over dt square. But when we put 3 pi over 4, then at t is equal to 3 pi over 4, you get d square a over dt square equals to 48 sine 2 into 3 pi over 4, cancel this, you get 2, and it will become 3 pi over 2, so it will be negative 48, because 3 pi over 2 is negative 1, so you will get it equal to minus 48, so which is less than 0, and this will give you the maximum value. So at t is equal to 3 pi over 4, we are getting d square over d square a over dt square less than 0. So as I told you here that we have to, because we were finding the greatest magnitude, so d square a over dt square must be less than 0 at some value of t. That value we have found, and that value is 3 pi by 2, 3 pi by 4, sorry, 3 pi by 4. And now at this value 3 pi by 4, we will find out the value of a. So value of a will be, as we have found, a is equal to minus 12 sine 2t. So this we are going to apply. So a is equal to minus 12 sine 2t. So the value of t is 3 pi over 4, so that's 12 sine 2 into 3 pi over 4, cancel it, and this will be equal to minus 12 and minus 1 equals to 12, because the sine 3 pi over 2 is minus 1. So 12 is the greatest value of the, or the greatest magnitude of the accelerations, 12 meter per second square. This is answer of the question. So this was part number 1. Now the second part is this. Actually I have used this space, no problem, I'll explain you. So this is the second part. So second part is, the diagram shows part of the curve y is equal to x plus 1 over x, and the lines y is equal to x is at x is equal to 2 and x is equal to 3. Okay, the values, this is x equals to 2 x equals to 3. Now calculate the area of the shaded region. This is the shaded region, this one, okay, and we are supposed to find out its area. Obviously, whenever you find out the area of the shaded region, you use the concept of integration, okay. So let's use integration. So you know, this is the curve, okay. You will integrate it and you will definitely minus the area which is coming under the line, so you will get this area, okay. So you will integrate this, the limits you are going to use 2 and 3, and you will minus from it, you will minus the area of the line, so that is x dx, okay, with the same limits 2 and 3, okay. So let's do it here. So it will be equal to 2 to 3 x plus 1 over x dx and minus area of the line, area under the line, not area of the line, area under the line, x dx. So if we separate them, it will be 2 3 x dx plus 2 3 1 over x dx minus 2 3 x dx. So you can see that this one and this one, they both are same, one is positive, one is negative, cancel. So here we get 2 3 1 over x dx, and the integration of 1 over x is equal to log of x, so log of x, and you will apply the limits, that is 2 and 3, and you get log 3 minus log 2, which is equal to log 3 over 2, and when you will use calculator to get the value, let's quickly do it. Log 1.5 is equal to 0.0405, so you can write it as 0.405 units, because this is area units here. So this is the answer of the question. I hope you have understood it. If any part is not clear in this video, you can call me at this number. I will explain you. No need to worry. This is my WhatsApp number. Okay, take care.